Hello and good evening everyone guys. I welcome once again you all to this wonderful platform by Unacademy NEET English. I believe that you all are doing great and have a good time. Well, my name is Kjeldahl and you can also call me your KK sir. Before we move ahead, I want quick confirmation that if you can see me clearly and hear me clearly, let me know in the chats. Let me know in the chats. Let me know in the chats if I am audible and visible to each and everyone there. Okay. I believe that we are live now and super excited to start today's session. And let me tell you, in today's session, we will be discussing 45 sure shot questions of organic chemistry. And be assured that around 13 to 15 questions will be there in your NEET paper. So, do share the stream with everyone preparing for NEET and be with me till end of this session. And I also would want you all guys to mark the attendance by smashing the like button. So let me know quickly in the chats. How is the Josh for this today's session? Because this session is gonna be very important for you preparing for NEET examination. So how is the Josh? How is the Josh? Hi, how sir? Hello? कर में मान इसना ओ इच्छा है मगर आते इको है वन अच्छा इको है वन इश्यात मस्त है वन लाइव मस्त क्लियर करो टच क्रॉस तो मत ममकिन वगैरह वीडियो कॉल से करता तो पेस याल आंख में वगैरह से वीडियो कॉल सोच Слышь? Слышь. Hello. На. Уйш кирю банд. Слышь, мगर माइक. करियो तो सुबह. Hello. एक सेकंड ये. तो बच्चे फोन पूछे लाइव उसमें जाइए सुध. ठीक. Am I audible and visible? Voice is not clear. Now clear. Is voice clear? Am I audible and visible? Let me know quickly. Let me know quickly in the chats. Come on, let me know. We have completed organic chemistry. My dear lovely student, we are completed. Okay, clear. Is this clear now? Everyone. Okay, that's great. That is great. Now, I would want you all guys to simply mark the attendance by smashing the like button and be with me till end of the session. So without wasting much more time, as the session is very important, let's get going. Let's start today's session. Now, first of all, the question is, the IUPAC name of the compound is. So the compound given over here is like this. You have to name the compound. But first of all, have a look. Here we have two types of, functional groups over here. One is this one. One is this one. This is known as an aldehyde, and this is ketone. Whenever you have two functional groups, one is aldehyde, another is ketone, aldehyde is at that time the principal functional group, and this ketone will act as a secondary what we call functional group, or it will act as a substituent. Now, what will we do over here? Have a look. Have a look. Have a look. Now we know this is our main functional group, principal functional group, and this is the chain terminating functional group. So this is 1. This is 2, this is 3, this is 4, this is 5, this is 6. So at second position it is methyl, so I will write down 2-methyl. It is 2-methyl. And at third position it is keto, so I will write down 3-keto. But among these two, I will write down that one first, which comes first in alphabetical order. It starts with K, it starts with M, so I will write down 3-keto, 2-methyl. So the name of this compound will be simply 3-keto, and after that it is 2-methyl. Then what is the word root? How many carbons are there in our parent chain? There are 6, so I will write down hex. After that, we have ene double bond at fourth position, so we will write down 4En. Because this E, we have to drop that E as functional group starts with a vowel, so it is 1-ul, or you can say it is 4-enol. Not necessary that you have to write down 1, because we know whenever functional group is CHO, as it is chain terminating functional group, it will be always present at position number 1. So what will be, the correct option among these 4? This is 5-formyl, no. 5-methyl, no. So 3-keto. That means either this or this. But this is 3-keto, 2-methyl, 3-keto, 2-methyl. After that, it is hex 5-enol. But we have hex 4-enol. So the right answer or the right option will be the option number 4. I hope this is clear to each and everyone. Let me know quickly, is this clear? Let me know quickly, is this clear? Let me know quickly. Am I clear till now? Am I clear till now? Let me know in the chats quickly. Clear. Shafkat Amin. Thank you, Veda. Thanks for responding. Quick. Okay. Kashu, thank you. Meena, thank you. Harshi, thank you. Avinandan, yes, great. Likhit, great. Renuka, nice. Mubina, great. Insha, great. Nuraj, that's great. Shafkat, great. Raji Sharma, great. So this is clear to each and everyone. After that, we will be having another question. And question is, how many stereoisomers does this molecule have? Simple, very simple question. As this molecule, first of all, you have to look whether is this, symmetrical or unsymmetrical. We know this molecule, this species is an unsymmetrical species. So this is an unsymmetrical species. For this, we will be having a formula like this. We can use a formula like this. That means number of stereoisomers. Number of stereoisomers. For this molecule is 2 raised to the power n. Now the question is, what is n? N means number of stereogenic areas. Number of stereogenic areas. Number of stereogenic areas. I mean to say number of GI areas as well as number of OI areas. That means number of geometrical isomer area as well as number of optical isomer area. Have a look. Have a look. We know that this carbon-carbon double bond, will show geometrical isomerism. That means it can show either E or Z isomer. Similarly, as this carbon, to which hydrogen on one side, bromine on another side, CH3 on another side, and CH2, CH double bond, CH CH3 on another side, as this is sp3 hybridized carbon and 4 different groups are attached. That means this is chiral center, which means this is an OI center, and at this position we will be having configuration R and S. That means in total we will be having, this is one stereogenic area, GI area, and this is OI area. That means we will be having 2 stereogenic areas. So here for this question, n is equal to 2. When n is equal to 2, so number of stereoisomers will be simply 2 raised to the power 2. So the answer is 4. That means its answer is simply 4, which clearly indicates that our first option is the right answer. So what are those 4 isomers? One will be simply E and R, another will be E and here configuration S, another will be Z configuration R, another will be Z configuration S. That means we will be having 4 stereoisomers over here. Now let me know in the chats, am I clear? Am I clear? Exactly, A is the right answer. Great, great everyone, great. That's great, that's great. Am I clear? Am I clear till now? Let me know clearly. Am I clear till now? Let me know in the chat quickly. Okay, this is very important session, as around 13 to 15 questions will be there in your NEET paper in 2026. So be there with me till end of this session, as this is very important for you NEET aspirants. Now have a look. A compound of molecular formula C7H16 shows optical isomerism. So the compound among these are having C7H16 formula. So which among these is a compound which can show optical isomerism? For that you must know, the structure of this compound. This is 2,3-dimethyl pentane. So I will write down a structure of this like this. So this is 2,3-dimethyl pentane. Have a look, my dear students. This is 1, 2, 3, 4, 5 pentane. That means on second and third position we will be having 2 and methyl groups at second and third position. After that we will be having 2,2-dimethyl, 2,2-dimethyl, and then butane, Have a look. After that, we will be having 2-methyl-hexane. So this is 2-methyl, and my dear students, this is hexane. Have a look. 1, 2, 3, 4. After that, it will be CH2, and after that, it will be CH3. Now, have a look. You have to find out, among these 3, that which of the compound can show optical isomerism. But for optical isomerism, we will simply see which of the following molecule is chiral molecule. Now have a look. As this is the chiral center, that means this molecule is having 2 chiral centers, but this is not a meso compound, because if you are having 2 or more than 2 chiral centers, but after that, if compound is a meso compound, that's optically inactive, but this is overall optically active. That means because of presence of these chiral centers, because of optical activity, this molecule is chiral, and hence it can show simply optical isomerism. But here no chiral center is present, so it cannot show optical isomerism. Here we will be not having any chiral center, hence this molecule is not chiral molecule. So this is not what we call a molecule which can show optical isomerism. So the option which can show optical isomerism is option number A. Now let me know quickly. Am I clear? Let me know in the chats quickly. Am I clear? Come on, you have to be with me. You have to solve these questions with yourself, so that you will check your knowledge, you will check where you are or where you exist as per organic chemistry is concerned. Okay, that's great, clear. After this, my dear students, we will be having another question. Question is Kjeldahl's method. Kjeldahl's method for the estimation of nitrogen can be used, because we know Kjeldahl's method is used as a technique for estimation of nitrogen. Now the question is the method for estimation of nitrogen can be used to estimate amount of nitrogen in which one of the following compounds? Now, you must remember that Kjeldahl's method is basically a method not used for those nitrogens which are present in ring like this, pyridine, or you can have a ring like this which is known as, say quinoline. Here nitrogen is also present in ring. Similarly, if you are having isoquinoline, here nitrogen is once again present in what we call ring. So whenever nitrogen is present in ring, Kjeldahl's method is not used to estimate, say nitrogen. Similarly, if there is azo compound, N double bond N group is there, azo compound is there, so it's not used. Similarly, if nitro group is there, then estimation of nitrogen is not used with the help of Kjeldahl's method. So Kjeldahl's method is not applicable to the compounds containing nitrogen either in, say the ring, whether it is pyridine, whether it is quinoline, whether it is isoquinoline. Similarly, whether it is, say nitrogen in the form of azo group or nitrogen in the form of nitro group. So this option number A, option number C, and option number D, these are, say the nitrogens which we cannot estimate, or the amount of which cannot be estimated by Kjeldahl's method. So which among these is then the compound whose nitrogen estimation can be done with the help of Kjeldahl's method? So the option or the answer is option number B. I hope this is clear to each and every one. Now, let me know quickly. Am I clear? Am I clear? Let me know quickly. Come on. Come on. This is very, very, very important session. Come on. This is very, very, very important session, guys. This is very important session. So, because 13 to 15 questions means it is 52 to 60 marks, to say. That will be there in your NEET examinations. So be ready, guys. Be ready. This is very, very important. Now, after that, we will be having another question. Question is, arrange the following in increasing order of stability. Let me tell you that whenever you are having stability of carbocation, you have to find out stability of carbocation. First of all, you have to check strain. Those carbocations whose strain is less, that means are more stable carbocations. After that, you have to check aromaticity. That means aromatic carbocations are more stable. After that, back bonding. That means the carbocation which are stabilized by back bonding, they are very stable. After that, you have to check resonance. After that, you have to check hyperconjugation. After that, you have to check what we call inductive effect. So this is basically the order in which you must check what we call stability of carbocations in general. But there are few, resonance stabilized carbocations which are lesser, less stable as compared to those in which hyperconjugation and inductive effect takes place. But we will not go there. First of all, we will see our question. What is our question? Question is, if you are having these types of carbocations, which is the most stable carbocation? Let me write down this carbocation in this fashion. It is like this. It is CH3 having a positive charge, then CH2, then CH3. Similarly, this carbocation is like this. CH3, then it is C, it is CH3, then it is CH3, then it's having a positive charge. My dear students, what is this? This is simply, third one is like this. It is CH3, then it is CH, then it is CH3 with a positive charge. Now, last one is CH3 with a positive charge. Now, as per strain is concerned or aromaticity is concerned, carbocations should be cyclic, but these are open structures. So no need to check strain or aromaticity. No need to check back bonding, because if back bonding takes place in carbocation, then carbocation is attached to an atom which contains lone pair of electron, because back bonding concept is only applicable if you are having two adjacent positions in such a way that one atom is having completely filled orbital and another is having empty orbital. So there is no back bonding, there is no resonance because there is no conjugation. So the effects or the factors there are hyperconjugation and inductive effect. So the combined hyperconjugation as well as inductive effect basically explains the stability of carbocation. But as per trick is concerned, we will give preference to hyperconjugation. So we will simply check out number of alpha hydrogens. So here number of alpha hydrogens are 8. Here number of alpha hydrogens are 9. Here number of alpha hydrogens are 6. And in this case number of alpha hydrogens are 3. So We will simply say more the number of alpha hydrogens, more will be the hyperconjugation, more the hyperconjugation, more will be the stability. So the most stable carbocation is B and the least stable carbocation is this E, because another is E. It's not having any say alpha hydrogen. So E is the least stable. That means among A or B, option will be say either A or B, because least stable is E. So it will be either A or B. So we will simply say that these are not the options. Now, after that, among A and B, we will check. After E, which one is more stable? It is D. Yes, both are correct. After that, it is, after that, this we will be having C. That means both are correct. But after that, we will be having first A and lastly, we will be having B. Now, have a look. E is least stable, but A is not most stable. E is least stable, but B is most stable. That means this is the correct option. So have a look and we will write down simply that E is least stable and B is the most stable because it's having 9 alpha hydrogens. So let me know in the chats, am I clear? Let me know in the chats, am I clear? Quickly. Let me know in the chats, am I clear? Quickly. Quickly, my dear students, let me know in the chats quickly. Am I clear till now? Am I clear till now? Okay, Krishna, thanks for replying. Likhit, thank you. Shubala, thank you. Parimala, good, great. Meena, great. Mubina, great. Asha, that's good. Sairam, good, that's good. Renuka, at the rate of user, good, great. At the rate of Rajesh, nice. At the rate of Avinandan, nice, that's great. At the rate of Vishwa, that's great. God bless you each and every one. Now, after that, we will be having another question. Which of the following statements is not correct for a nucleophile? Now, what is nucleophile basically? You know, nucleophile means nucleus loving species and it always donates its electron to electron deficient site of the substrate. But when it donates its electron, it will be either, say a neutral species generally, or it will be a negatively charged species. When it donates its electron, that means it generally donates its electron pair, and any electron pair donor is known as a Lewis base. Now, what we have to, check over here, which of the following statements is not correct? Is not correct for nucleophile. So, nucleophiles are Lewis bases. Here, nucleophile is a Lewis acid. No, this is wrong. Now, after that, ammonia is a nucleophile. Ammonia is this. Yes, ammonia can act as a nucleophile by donating its electron to electron deficient site of the substrate. That means this is exactly correct. Nucleophile, ammonia can be a nucleophile. Nucleophiles attack on less electron density sites. Yes, obviously, they basically attack electron deficient site. That clearly means less electron density site. This is also correct. Nucleophiles are not electron seeking. Yes, they are not electron seeking. They are, electron deficient site loving or less electron and density site loving. That means they are nucleus loving. So which one of these is incorrect? So obviously it will be first option, that nucleophile is a Lewis acid. This is very simple question. But let me tell you that if your basics are very clear, then each and every question seems to be very simple. Now, am I clear till now? Am I clear till now? Am I clear till now? Quickly. Let me know quickly. Am I clear? Am I clear, my dear students? My dear lovely doctors? Come on. Oh, thank you very much, Said Yasmina. I'm not king, basically. No one is king in this world. But thank you. God bless you all. God bless you. God bless you, each and every one. It's clear to each of you. Now, after this, we will be having another question. And question is the alkane that gives only one monochloro product, on chlorination of chlorine in presence of diffused sunlight. Have a look. We know on monochlorination of alkane. We know on monochlorination of alkane, number of monochloro products, number of monochloro derivatives or products. You can simply say number of monochloro derivatives or number of monochloro products formed from any alkane is equal to number of different types of, hydrogens actually. Number of different types of hydrogens actually. Now, this is basically the formula. So, have a look. First of all, we are having isopentane. We will be having isopentane. Iso group is this one, and then we will be having total 5 carbons over here. So this is isopentane. We know in case of isopentane, we know that this is, type A carbon, and hydrogens attached to type A carbon are type A hydrogens. Similarly, this is type B carbon, this is type C carbon, this is type D carbon. Now, would this type A, B, C, D, it depends on what? It depends on what? It depends on basically the 4 groups attached to this carbon or the surroundings of this carbon, and 4 groups attached to this carbon, they are same. Because here 3 hydrogens are attached, and in addition to that, we will be having this CH, CH3, CH2, CH3. Similarly, here this is having 3 hydrogens, and after that CH, CH3, CH2, CH3. But this is having CH3. After that it is CH2, not CH. That means these two are similar. This is different. This is already different, and this is different. That means there are 4, types of carbons. Hence, 4 different types of hydrogens are there. So it will form 4 different monochloro products. But we have to find out that alkane which gives only 1 monochloro product. After that, let us draw the structure of this. This is 2,2-dimethyl. 2,2-dimethyl, and after that it is butane. It is butane. Have a look. This will be having simply this, this, and this. All are, same types of carbons, so same types of hydrogens. This is having different, this is having different. So there are 3 different types of hydrogens. So it will result in the formation of 3 monochloro products. But what about neopentane? This is neopentane, CH3, C, CH3, then it is CH3, then it is CH3. So this is neopentane. Neopentane is having only 1 type of carbon. That means only 1 type of hydrogen. This is having basically only 1 type. This is having 2 types of carbons, but this carbon is not, needed right now, because we basically want those carbons only which contain, hydrogens. So we will be, write down the number of those, carbons only which will be having hydrogens attached to that. So only 1 type of hydrogen is present. Here 3 types of hydrogens are present. Here 4 types of hydrogens are present. So this will result in the formation of 1 monochloro product. So this will be the answer. But first of all, we will check out last option as well. This is N-pentane. This is N-pentane. Now in this N-pentane, we will be having this and this similar type, this and this similar type, and this is different. That means 3 different types of hydrogens. So 3 different monochloro products. Here 3 different monochloro products, 4 different monochloro products. This is having only 1 monochloro product. So our answer will be neopentane. Now let me know quickly, am I clear? Let me know quickly, am I clear? Is this clear to each and every one? Am I clear? Am I clear? 4313. Said Yasmina, 4313. God bless you. Our exact right answer. So great. That means it's clear to each and every one. My dear future doctors, that's great. Okay, thank you at the rate of king that say clear and loud. Thank you. God bless you. Now after that, we will be having another question. Hydrocarbon A reacts with, let us check out, have a look. Hydrocarbon A reacts with bromine by substitution to form alkyl bromide. First of all, this cannot undergo substitution with bromine. This cannot undergo substitution with bromine because here addition of bromine will take place in these 2 cases. So our A will be either this or our A will be like this. After that, which by Wirth's reaction is converted to? Gaseous hydrocarbon. Have a look, my dear students. We will be having some hydrocarbon. We don't know the hydrocarbon, but it's clear from these options that hydrocarbon is an alkane. It can never be an alkyne, it can never be an alkene, because bromine with alkyne and alkene this alkyne, that means ethine, and with this alkene, that means ethene, undergoes addition reaction, bromination, not substitution. Now, first of all, this undergoes substitution with bromine, and it results in the formation of alkyl bromide. After that, this upon What's condition? On treatment with sodium and dry ether, we know whenever alkyl halide is treated with sodium, we have to break CX bond and we have to form a radical on that carbon to which halogen is attached. That means here our radical will be formed, and this undergoes combination and it results in the formation of RR and alkane. So can I say the radical formed over here is R radical, but alkane is RR. That means alkane is always a dimer of this one. Alkane is always dimer of this. Have a look. If we take CH4, then it is CH3 radical. We will get CH3, that means ethane. But if we take CH3, say alkane, then this is CH3, radical. If this is CH3, radical, we will get CH3, CH2, that means butane. But question says, that means gaseous hydrocarbon is obtained, but this contains less than 4 carbon atoms. This must have less than 4 carbon atoms. But if this is Ra, then we will get N-butane, that means 4 carbon atoms. But if this is Ra, we will get ethane, less than 4 carbon atoms. So which will be simply the option? Option will be option number C. So I hope this is clear to each and every one. Let me know quickly. Am I clear till now? Am I clear till now? Because this is very, very, very important session. Come on, my dear students. Let me know. Let me know quickly. Am I clear? Okay, thank you. God bless you. God bless you. Yeah, if your basics are good, Abdul Maulana, then these sessions are more than sufficient. But I simply suggest you that, first of all, you at least go through my, one-shot video lectures, first of all. After that, top 20 concepts. And after that, you will, check out these sessions as well. That will definitely help you. And if around 14 to 18 questions will be there, you will at least you will what we call complete there 15 questions at least you will do 15 questions in your NEET examination out of 18 at least. But if your basics are already clear, if you have studied all those chapters which we have already discussed in one shot, then 18 out of 18, 15 out of 15, 14 out of 14, depends upon how many questions will be asked. Now, another question is dihedral angle of least stable conformer of ethane is. We know in case of ethane, I mean to say, if we talk about CH3, if we talk about CH3, C2H6, ethane, we will be having infinite number of conformations. But among these, the extreme two forms, that means one is, among these extreme two forms, one is eclipsed and another is staggered. These are important for us. And all other forms will lie in between them, and those forms will be known as skew forms. Here, dihedral angle is 0 degree, and here, dihedral angle is 60 degree. We know that. And we know in eclipse form, say for example, if I write down the structure of ethane as per Newman projection is concerned. So this is CH3, and after that, and another carbon, this is CH3. So these hydrogens, if I talk about this hydrogen and this hydrogen, say for example, which are present on two different carbons, their bond angle is what we call 180. But if we talk about this hydrogen and this hydrogen, these are present at different carbons, their bond angle is what we call their angle is what we call 60 degree. So whenever there is angle between this hydrogen and hydrogen which are present at different carbons, this is known as dihedral angle. So its dihedral angle will be either what we call 60 degree or dihedral angle will be what we call 180 degree. We know that this form is what we call staggered form, but another form in which the smallest dihedral angle is like this. If we write down H like this, H like this, and H like this. So here, what is the dihedral angle between these two? Here it was 60, here it is what we call 0 degree. But when your form is like this, it's having 0 degree dihedral angle, that means it's eclipse form. At that time, can we say electron cloud of this CH bond and CH bond, electron cloud of CH bond and CH bond, they are very, very closer to each other. Hence, there will be electronic repulsion. There will be electronic repulsion, or we can simply say there will be a torsional repulsion, torsional strain. But this staggered form is free from torsional strain. There is no electronic repulsion because these are far away from each other. But here, as electronic repulsion is there, torsional repulsion is there, torsional strain is there. Because of that, energy will be increased and its stability will be decreased. Hence, in case of ethane, this is the least stable form where theta is what we call 0. That means where dihedral angle is 0. So this will be the answer because this is the least stable conformation because of highest torsional strain or highest electronic repulsions between electron cloud of CH bond and electron cloud of CH bond. I hope this is clear to each and every one. Let me know quickly. Am I clear? Let me know quickly. Am I clear till now? Am I clear till now, my dear lovely doctors? Am I clear? Am I clear? Yes. Yes, that's great. That's great. That's great. That is great. That is great. Have a look. Have a look. We will be having another question, and question is like, the major product of the following chemical reaction is, but have a look, this is an unsymmetrical substrate, unsymmetrical alkene. This is also an unsymmetrical substrate, and that too HBr, and this is what we call a peroxide. Remember, if whenever you are having these three things, number one, whenever you are having an unsymmetrical alkene, number one. Number second, you are having HBr, and number third, you are having peroxide. At that time, reaction is, forming a product, and that product is according to N-T-Markovnikov's product. So product will be N-T-Markovnikov's product, and this addition will be free radical addition reaction. That means intermediate will be simply a free radical. Intermediate of this reaction is always free radical. You know that intermediate here is the free radical. So we have to add HBr across carbon-carbon double bond, but according to N-T-Markovnikov. What was Markovnikov? Markovnikov says that negative part of this addendum goes to that carbon-carbon double bond which is having lesser number of hydrogen. That means according to Markovnikov, Br should go here and H go here. But we have to, form the major product of this reaction, but N-T-Markovnikov. That means we have to switch these. That means that clearly indicates that H will go over here and Br will go over here. That means our product will be CH3CH3. After that, it will become CH2, it will become CH2Br. That means option number second will be the right answer. Now, let me know, is this clear? Is this clear? That whenever you see these 3 points, product should be according to N-T-Markovnikov's product. Let me know, am I clear? Let me know quickly, am I clear? Let me know quickly, am I clear? Am I clear? Am I clear, my dear students? Exactly, Vishwa King. It will be B. Yes, user clear. Clear, Asha. That's great. That's great. That's great. Show some Josh as well, as this is very, very important. Session. You can show some Josh with fire emojis, with, green heart. Okay, come on. Come on, my dear students, my dear doctors, come on. Come on. Yes, that's clear, that's clear, that's great. Now, another question is like this. An alkene A on reaction with ozone and zinc H2O. First of all, whenever ozone zinc H2O is there, you know this is reductive ozonolysis. This is reductive ozonolysis. So alkene on reductive ozonolysis gives propanone. Let me write down propanone like this. This is propanone. And ethanol. That means it is like this. It is like this, my dear students. Now, this is formed, this and this. These are formed on reductive ozonolysis. I mean to say these are formed upon reductive ozonolysis of an alkene. We don't know what is the alkene, but that alkene is alkene A. Okay. Now, addition of HCl to alkene A, then addition of HCl to this, addition of HCl to this gives B. But we have to find out what is B. But for that, we must know what is A. We must know what is A. So, how to find out A? We know whenever we are having ozonolysis products are given, we have to find out the reactant. Then we have to just remove this oxygen and this oxygen. After that, form a double bond over here. That means alkene A is simply like this. CH3, then it is C, then it is CH3, then it is double bond CH, single bond CH3. So this is an alkene. So this is an alkene containing 4 carbons in our parent chain, and this is simply 1, 2, 3, 4. This is 2-methyl butene. This is 2-methyl butene. Now we have to add HCl to this. What will happen? How it, takes place? This is simply an electrophilic addition reaction taking place via classical carbocation. So first of all, carbocation will be formed, and that carbocation will be formed like this. This will be the stable carbocation. You have to form more stable carbocation. Now this will be the carbocation over here, and H will be added to this. So this will be the carbocation. Finally, Cl minus will attack, because there will be no rearrangement. Otherwise, we have to check whether rearrangement, whenever rearrangement takes place, that means it becomes more stable carbocation. But this is already stable carbocation because of, 8 alpha hydrogens. So there will be no further rearrangement. So this Cl minus will attack, and we will get CH3, C, Cl, CH3, then CH2, CH3. So this is RB. This is RB. So my dear student, this is the B. Now have a look. What is B? B is simply 2-chloro-2-methyl butane. 2-chloro-2-methyl butane. So 1, 2. 2-chloro-2-methyl butane. So this is our B. I hope this is clear to each and every one. Now, let me know. Am I clear? Let me know quickly. Am I clear? Am I clear? Am I clear till now? Have a look. Have a look. Am I clear till now? Am I clear till now? Come on. Let me know quickly. Yes, that's great. God bless you. God bless you all. After that, we will be having another question. Question is, in the following reaction, in this one, addition of water in presence of acid to alkene results in the formation of 2 products. One is alkene, one is the product that's minor product, another is major product. We have to find out the major product. So we will be performing this equation like this. Have a look. This is an alkene. This is an alkene. We have to do acidic hydration. That means, first of all, in presence of acid, it will result in the formation of a carbocation first. So it will result in the formation of carbocation first. So I will form more stable carbocation, can form over here as compared to this. So first of all, this. After that, my dear students, this carbocation will undergo rearrangement. That means 1,2-methyl carbanion shift. It is not methyl shift, it is methyl carbanion shift. It's methyl with negative charge which is shifting. Now, so 1,2-methyl carbanion shift is there. So positive charge will be present over here, and after that it will result in the formation of this carbocation. Why this shift has been taken place? Because this was, stable because of this, inductive effect of tertiary butyl, and inductive effect as well as hyperconjugation of methyl, but this is having inductive effect of this and this as well as hyperconjugation of these two, and inductive effect of this as well as hyperconjugation. In nutshell, more number of alpha hydrogens are there, so more stability will be acquired by this. After that, finally, water will attack. Nucleophile, water will attack, and it will attack to this position. When it attacks this position, O becomes positively charged. Finally, it will lose H positive. So let me write down the final products, because it loses H positive. Whenever neutral nucleophile attacks, it loses H positive finally, and it will result in the formation of a final product. That final product will be like this. That final product will be like this. That means this is 1, this is 2, this is 3, this is 4. So this is basically 2 and 3 dimethyl and then butane 2-ol. This will be the major product. Have a look where this product is. Where this product is. This product is present at position number 1. Position number 1. This is the product. This is the product. Now, let me know quickly. Am I clear? Let me know quickly. Am I clear? Am I clear? Come on, my dear students, because this is very, very important session, as I have assured you that your NEET paper will be simply from these, say around 13 to 18 questions will be there in your NEET examination. So am I clear? Yes, clear. God bless you. Now, after this, we will be having another question. Question is like this. First of all, we will be having this one, CH3, then it is CH3, then it's CHOH, then it's CH3. I mean to say we will be having what we call 3-methyl butane 2-ol. This upon heating. This upon heating in presence of H positive. What will happen? First of all, protonation of this alcohol will take place. When protonation takes place, it will result first of all in the formation of this. It will result in the formation of this. It is CH3, then it is CH or H over here. After that, it is CHOH2, OH2 with a positive charge. Now, first it was not a good leaving group. Now it becomes a very good leaving group. It will leave. When it leaves, it results in the formation of a carbocation. So it results in the formation of a carbocation, and our carbocation will be like this. Carbocation will be like this. After that, can we simply say that there will be a rearrangement, and rearrangement will be of hydride shift. So I will simply write down 1,2 hydride shift. After that, a new carbocation, more stable carbocation will be formed. So this is the more stable carbocation which is formed. And after that, we know it will lose H positive. But from the position which is adjacent to the carbocation. But let me tell you that here, this carbocation, this position, they are similar positions, and this is different. So this with respect to hydrogen is rich, because this is having 3 hydrogen, but this position is poor with respect to hydrogen. And we know whenever base abstracts hydrogen, that base will abstract hydrogen from either A position or B position, that means from the position adjacent to the carbocation. If base abstracts hydrogen from rich position, product will be like this, and this product is known as Hoffman product. You know that. Product is known as Hoffman's product. And if base abstracts hydrogen from B, that means from poor position, then another product will be like this, and this product is known as Sadzeff product. This is known as Sadzeff or Zetsue product. And we know this reaction from this to this is basically elimination, as OH has been removed as well as H has been removed. So from this to this is elimination. But taking place via formation of a carbocation is simply E1 elimination reaction. And E1, during E1, we know Sadzeff is always major product. Sadzeff is always major product because this is more stable, alkene. This is more stable alkene, more alkylated alkene. This is less alkylated alkene, less stable alkene. So this is major, this is minor. But what we have to do, what we have to find out, A is major, so this is major. So this is A. And this is B, because B is the minor product. After that, this A on treatment with HBr, This A on treatment with HBr in absence of peroxide. So let me write down this A. Let me write down this A. What is this A? This is 2-methyl butyene. 2-methyl butyene. Have a look. 2-methyl butyene on treatment with HBr. On treatment with HBr, but in absence of peroxide. That means it is normal electrophilic addition reaction taking place via classical carbocation. So first of all, we will form a carbocation after protonation. Now, Br minus will be lost. A carbocation will be formed like this, CH3C, CH3. Then here, a carbocation will be formed because this is more stable carbocation. Here, H will be added. And this carbocation, after formation of this carbocation, there is, as we know, there will be no rearrangement. Now, after that, this Br minus will attack, and this attack is a very fast step, and this carbocation formation is a rate determining step. So we will get like this. We will get like this. So this will be the product. So what is this? This is 2-bromo, 2-methyl butane. Now have a look towards the question. Now it will result in the formation of C and D. It will result in the formation of C and D. A will form C and D. But which one is the major? Major is C. That means this is C. This is C. Now, how will it form D? Have a look. If positive charge is present over here, positive charge is present over here. Have a look. Positive charge is present over here. After that, you will form, rearrangement and all that, and form the more stable, and form another product. But what we have to do is, we have to find out A and C. So no need of formation of D. So this is A. A is this one. That means A is CH3, CH3, double bond CH3. That means 2-methyl butene. But this is not 2-methyl butene. This is 2-methyl butene. This is 2-methyl butene. So this is, 2-methyl butene. After that, we have to find out C, because C is also the major product. We have to find out A and C only. C is the major product. C is basically 2-bromo, 2-methyl butane. 2-bromo, 2-methyl butane. That means our answer will be simply option number B. 2-bromo, 2-methyl butane and 2-methyl butene. I hope this is clear to each and everyone there. Let me know quickly. Am I clear? Am I clear, my dear students? Am I clear? Let me know quickly, my dear lovely students. Come on. Let me know. Kanmani, thank you, everyone. That's great. After this, my dear lovely students, we will be having another. The most suitable reagent for the following conversion is. Now, have a look. This is an alkyne. This is alkene. From alkyne to alkene, but that too cis. Remember, if you are having an alkyne, from alkyne to alkene, but if alkene is trans, then it is Birch reduction. That means sodium in presence of liquid ammonia or lithium in presence of liquid ammonia. That means it can form what we call a trans product. But from this to this, from alkyne to cis, we will use H2 in presence of PDC or H2 in presence of PDCaCO3 with small amounts of sulfur or quinoline. That means we will use Lindlar's catalyst, or we will use H2PD but in presence of BaSO4. That means we can also use, or in BaSO4 sulfur or quinoline, we can use Rosenmund's catalyst as well. Or either you will use Lindlar's catalyst or Rosenmund's catalyst. So this is the right option. But in presence of zinc HCl, no, it will not react at all. Now, after that, this is what we call alkyne in presence of Hg2 positive, Hg positive, water is added. This is known as addition of water or hydration to alkyne. It will first of all result in the formation of an enol, and after that it will form what we call carbonyl compound. But here product is alkene, so this is not the right reagent. This reaction is known as Kocherow's reaction. So we will never use these reagents. So this is the appropriate reagent, or this is the reagent which can convert alkyne to cis alkene. Let me know quickly. Am I clear? Let me know quickly. Am I clear? Dear students, let me know quickly. Am I clear? Let me know quickly. Am I clear? Okay, that's great. After this, we will be having another question. Which of the following chemical system is non-aromatic? You know, for aromaticity, basically, aromatic compounds are very stable as compared to non-aromatic compounds, and non-aromatic compounds are very stable as compared to anti-aromatic compounds. This is basically the stability order which will decide which one is aromatic, which is non-aromatic, which is anti-aromatic. But for the simplicity, or for the sake of simplicity, we generally uses, conditions. Now for those conditions, what are the conditions for molecule or a species to be aromatic? Number first, there must be complete cyclic conjugation. Complete cyclic conjugation should be there. And number second, 4n plus 2 pi electrons should be there. And for non-aromatic species, or we can simply write down first of all aromatic species, after that anti-aromatic species. Number first, complete cyclic conjugation should be there. Complete cyclic conjugation should be there. That means compounds must be cyclic and there must be complete delocalization or conjugation. Okay. After that, second, it should obey, or it must have 4n pi electrons. If compound is, neither this nor this, then compound is non-aromatic. That means acyclic species, open chain structures, are neither aromatic nor anti-aromatic. They are always non-aromatic. But here, all the species are what we call cyclic. Now, how to find out whether which one is, acyclic and which one is aromatic, which one is not aromatic? How to find out? Have a look. We know that here, as pi bond is formed, so I will write down that there are p orbitals over here of carbon. So at least if 3 positions are having p orbitals or d orbitals parallel and within the same plane, we simply say conjugation is present. So here conjugation is present, as these are sp2 hybrid orbitals. Sp2 hybrid orbitals are having pure p orbitals like this. So they are in parallel or same plane and at least at 3 adjacent positions. So they are present at 4 positions, hence conjugation is present. But as this carbon is sp3 hybridized, sp3 hybridized carbon does not have any p orbital available. So there will be no p orbital. So conjugation is from this to this, but not completely to, this ring. So there is conjugation, but there is not complete cyclic conjugation. Whenever there is no complete cyclic conjugation, compound is known as simply non-aromatic. So this is non-aromatic. So this is our option. Now here, it's p orbital which have basically overlap. So p orbitals are there. So when you are having at least 3 p orbitals at 3 adjacent positions or parallel and within the same plane, conjugation is there. Here complete cyclic conjugation is there. So it can be either aromatic or it can be anti-aromatic. But now in this complete cyclic conjugation, pi electrons are there, 6 pi electrons are there. That means it obeys 4n plus 2 pi electron system. So this is aromatic system. Similarly, in this monocyclic species, sulfur is having 2, lone pairs, but one lone pair is present in a p orbital, which is basically parallel with these p orbitals. Another is present in p, but that is not, parallel with these three. So we will not consider this p as this is not parallel. Now after that, we will say here is complete cyclic conjugation, and that too, 2 pi electrons, and these 2 pi electrons, because all those electrons which are present in conjugated orbitals are, we have to count those electrons. So here 6 pi electrons are there. So we will simply say this is also aromatic. So aromatic and aromatic. But this is not a monocyclic species. This is a bicyclic species, that too in which, at least 2 atoms are common in between. That means these are fused rings. For fused rings, we have to check conjugation at large path or periphery. We have to check large conjugated path. Have a look, my dear students. So large conjugated path is this. You can see conjugation is there, or large path. And that too, how many pi electrons? 2, 2, 4, 6, 8, 10. That means this is also aromatic with 10 pi electrons. So this is aromatic. This one is aromatic. and this one is aromatic. So these are all aromatic except first one. First one is non-aromatic because of presence of sp3 or because of what we call absence of complete cyclic conjugation. Hence, first one is non-aromatic. Let me know quickly, am I clear? Let me know quickly, am I clear? Let me know quickly, am I clear, my dear lovely students? Let me know quickly. Come on. Come on, doctors. Come on, my dear doctors. Yes, it's clear. Sairam, thank you. Kushal, thank you. Meena, thanks. Asha, that's great. Thank you. God bless you all. God bless you all. Kanmani, everyone. Thank you. Thank you. Thank you. God bless you. After that, we will be having another question, that is, have a look. Question is like, toluene on reaction with chlorine. Toluene. This is toluene. Methyl benzene. Toluene. On reaction with chlorine. On reaction with chlorine, that means chlorination, in presence of FeCl3. So remember, whenever reaction is this, they will result in the formation of Cl positive as an electrophile. So this is electrophilic substitution reaction, and as we know, this CH3 is electron donating group because of hyperconjugation, and it will increase electron density at ortho and para position of this benzene ring due to hyperconjugation. Hence this is ortho para directing. That clearly indicates here products will be orthochlorotoluene as well as para-chlorotoluene, but we know this para one will be the major product because here steric repulsion will be this. Okay, after that, and reaction in presence of light, same toluene reacts with chlorine but in presence of light. At that time, this reaction is basically, this is free radical substitution reaction. This is benzylic halogenation. Now, what will happen? Benzylic hydrogen will be replaced. Benzylic hydrogen will be replaced. First, it will result in the formation of benzyl chloride. After that, another hydrogen will be replaced and it will result in the formation of benzyl dichloride. After, it will result in the formation of benzo trichloride if chlorine is taken in excess. Now, have a look. What is the, question now? Question says, whenever toluene reacts with chlorine, it results in the formation of what? And when it reacts with chlorine in presence of light, it will result in the formation of what? So here, this is what we call, according to the question, this is X. This is X, and according to the question, this is what we call Y. Now, we have to find out what is X and what is Y. So, reaction of toluene with chlorine in presence of FeCl3 gives X, and reaction in presence of light gives Y. Thus, X and Y are, X is ortho and para. X is ortho and para. This is not X, this is not X, this is X. That means this is the what we call right option, because only one option is this, that X is having ortho and para-chlorotoluene. So this is X. After that, what is Y? Y is obviously trichloromethyl benzene. That means this is benzo, what we call trichloride. So this is trichloro, what we call methyl benzene. This is trichloromethyl benzene is our Y. So option C is the right answer. Simple, very simple, very simple. Now let me know quickly. Am I clear? Is this 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 clear, my dear students? Is this clear? Come on, quickly. Okay, clear, sir. Thank you. Now, another question is, which of the following compounds reacts slower in electrophilic substitution reactions? For electrophilic substitution reactions, remember. Electrophilic substitution reaction basically depends on the electron density of the ring. That means electrophilic substitution reaction rate is simply directly proportional to electron density. It is directly proportional to electron density of the ring in aromatic compound. So more electron density is present in the aromatic ring of an electron density of aromatic ring of an aromatic compound, more faster will be the electrophilic substitution reaction. Now the question is slower. Slower means electron density will be very less. That means when electron density is more, that means benzene ring or aromatic ring should be attached to electron donating ring. Electron donating group. But if that ring is attached to electron withdrawing group, what will electron withdrawing group do? They will simply withdraw electron and decrease the electron density of the ring. When electron density is decreased, rate of electrophilic substitution will be decreased. So here slower. Slower means where rate of electrophilic substitution will be less. I mean say rate should be less. This is NO2, electron withdrawing. OH, donating due to, I mean to say resonance. This is donating due to inductive effect as well as what we call hyperconjugation. This is donating due to resonance. Now, so simply our answer will be this, because this NO2, sorry, this NO2 is electron withdrawing. It will withdraw electron density from the ring, and electron density of the ring will be decreased. When electron density of ring decreases, rate of electrophilic substitution reaction will get lowered. Now, let me know quickly, am I clear? Am I clear? Am I clear? Am I clear? Quickly, quickly, quickly. Okay, yep, super. Okay, sir, clear. Premala. Thank you, thank you, thank you, thank you, everyone. After this, we will be having another question. Predict the order of reactivity of the following 4 isomers towards SN2 reaction. You know this one. You know this one, that rate of SN2 reaction is inversely proportional to steric crowding. It is inversely proportional to steric crowding at alpha or beta positions with respect to leaving group. Beta positions with respect to leaving group. And for that purpose, in general, we will say tertiary alkyl halide is, this primary alkyl halide shows SN2 faster as compared to secondary, as compared to tertiary. So have a look. These are all primary, these are all alkyl halides. This is a primary carbon to which halogen is attached. So this is a primary alkyl halide. This is a secondary carbon. So this will be a secondary alkyl halide. This is a primary carbon. So primary alkyl halide. This is a tertiary carbon. So tertiary alkyl halide. So tertiary will be at last. That means 4 will be at last. That means either C or D is the correct answer. After that, it will be what we call 2. 2 will show more faster reaction as compared to 4. So 2 greater than 4. So our question answer will be, say option number D. So why? This is primary, but this primary alkyl halide is having branch at beta. This is not having any branch either at alpha or at beta. So if branching at beta increases, alkyl groups at beta increases, steric crowding increases, rate of SN2 will be lesser, decreased. So we will be simply saying that 1 degree alkyl halide, this one, which is not having any branch at alpha or beta, this shows faster SN2. After that, this 1 degree in which beta hydrogen is having branch, after that it will be secondary, after that it will be tertiary. That means 1, 3, 2, 4 will be the right answer. 1, 3, 2, 4 will be the right answer. Now let me know quickly, am I clear? Am I clear? My dear lovely students, let me know in the chats, am I clear? Am I clear? Am I clear? Let me know quickly. Let me know quickly. Am I clear? Everyone, come on, everyone. Come on, everyone. Let me know quickly. Let me know quickly in the chats. Am I clear? Am I clear, my dear lovely students? Come on, show some Josh, come on. Am I clear? Till now. Okay, that's clear, that's great. Yeah, I will be definitely sharing this, PDF of this session on Unacademy Telegram channel. Obviously, Unacademy NEET English. I will be sharing that with you as well. But first of all, it's another question, an SN1 reaction on chiral center. Have a look. It's on chiral center, SN1 reaction. There is, what will happen during SN1? Recall your, SN1 reaction. Say for example, your SN1 reaction is like this. This is having, say you are having a phenyl ring over here. After that, you are having ethyl. After that, you are having, say for example, methyl over here. This is priority wise, this is having number 1, this is having number 2, this is 3rd priority group, this is 4th priority group, as this is the chiral center from 1, 2, 3, configuration is S. So at this chiral center, if if SN1 reaction takes place. Say for example, in presence of polar protic solvent, say for example water, ionization will take place. Ionization will take place, my dear student, ionization will take place like this. Say this is pH, after that this will be ET, and say for example this is methyl, and it will result in the formation of a carbocation and what we call Br minus as well, I mean say leaving group as well. But first of all, this is known as intimate ion pair. Intimate ion pair, you know that. Or this is what we call contact ion pair. Contact ion pair. Or this is also known as tight ion pair. That means this is an ion pair which is not separated by solvent. This is not solvent separated ion pair. This will first form. After that, what will happen? What will happen? Let us suppose nucleophile is water. Solvent acts as a nucleophile, suppose. Then whenever solvent acts as a nucleophile, reaction is also known as solvolysis, or water is the solvent, so it can be also known as hydrolysis. So can I say it cannot attack from front side, as this Br, this leaving group or electron cloud of this leaving group will repel, I mean say incoming what we call nucleophile. So nucleophile will attack from the backside. Backside means from the opposite side to that of the leaving group. So that is known as inversion. That means first of all backside attack will take place. From sp2 it will become sp3 once again. It will become tetrahedral once again. When it becomes tetrahedral, so we can write down in this fashion the structure. So once again, this is a chiral center. This is 1, priority number 1, priority number 2, priority number 3, priority number 4. Do you know this one? Then after that, this is the configuration R. So whenever SN1 reaction takes place at chiral center, if starting material is S, this inversion product will be R. If starting material will be R, inversion product will be S. But after some time, that means when these ions will be separated by solvent separation takes place. After that, this carbocation, there will be no Br minus, then this nucleophile will attack from front side as well as from back side. That means this is inversion product. This is inversion product first of all. After that, inversion as well as retention both will take place. After that, have a look, inversion as well as retention both will take place. This inversion chiral center 1, 2, 3 and 4. That means this R as well as let me write down over here, as well as this can take place. I mean to say that first of all, this is the chiral center. First of all, inversion takes place. After that, inversion as well as retention will be, I mean say, exactly equal. So this is retention. Why? Because configuration of chiral center is retained. Now tell me, my dear students, can I say first only inversion takes place? After that, inversion and retention are equally formed. That means, that clearly indicates, suppose first of all backside attack takes place due to this intimate ion pair. So let us suppose 2% of this has been formed first. After that, these both will form 98%. In nutshell, it's not 100% racemization, 100% racemic mixture is not formed, because it's not 50% and 50%, I mean say R and S, or 50% one enantiomer, 50% another enantiomer. It's only, let us suppose 49 and 49. But why this is having 49 and 49? Because 2% suppose is formed first. In nutshell, can I say inversion in total will be 49 plus 2. That means inversion will be greater than 50%. Whenever inversion is greater, inversion is more, and in, I mean say, what we call SN1 reaction, it's all because of intimate ion pair formation. So can we say in SN1 reaction racemization is 100%? Answer is no, it is lesser than 100% due to formation of this, or due to formation of what we call intimate ion pair. So inversion will be more than retention, leading to partial racemization. So this will be the answer. I hope you know this thing. So this is clear to you all. Let me know in the chats quickly, am I clear till now? Let me know quickly, am I clear? Am I clear till now? Am I clear till now? Am I clear, my dear students? Am I clear, dear students? Let me know in the chats quickly. Okay. Okay, that's great. Now, is it still lagging? Is it still lagging, or it's okay? Now let me know quickly, is it still lagging or it's okay? Is it still lagging or is it okay, my dear doctors? Come on. Come on. Come on, my dear doctors, because after a few days, most of the students among you will be the doctors. Come on, that's clear, smooth. Okay, great. Now, after this, we will be having another reaction or a question. Question is like this. Have a look, dear students. It's ethanol. Let me write down over here. It's ethanol. Ethanol is this one. On treatment with PBr3. On treatment with PBr3. We know whenever alcohol is treated with PX3, remove OH and replace that OH by X. So X is Br. So we will get CH3CH2Br. This is an alkyl bromide which is obtained. After that, alcoholic potassium hydroxide is there. Whenever alcoholic potassium hydroxide is there, alkyl bromide on treatment with what we call alcoholic potassium hydroxide, it is an E2 reaction. If it is aqueous KOH or NaOH, then it will be SN2 reaction. But here it's alcoholic, so replace simply bromine from alpha and hydrogen from beta. That means it is simply an E2 reaction. So after that we will get an alkene. So this is X, this is our X, this is Y. After that, this alkene on treatment with, number one, H2SO4. Have a look, H2SO4 at room temperature. First of all, it will simply addition will take place according to electrophilic addition reaction. So it will result in the formation of, first of all, alkyl hydrogen sulfate. Hydrogen will be added, carbocation will be formed, and to that carbocation, this OSO3H minus will be added. So alkyl hydrogen sulfate will be formed. But in second, you have to heat this with water. That means water and heat. Whenever alkyl hydrogen sulfate is heated with water, what will happen? This OSO3H will be replaced by OH of water. So the product is CH3CH2OH. So this is our what we call Z. So what is the question? The product Z is, you have to find out Z. Now tell me, what is Z? Z is CH3CH2OH. But if this water and heat was not given, say for example, then our Z will be at that time CH3CH2OSO3H. That means this one. But as water and heat is there, then we will get alcohol. I hope this is clear. Let me know quickly. Is this clear? Am I clear? Let me know quickly. My dear students. Am I clear? Kanmani is showing some buffering. Is everything clear? Is video clear? Is my voice clear? Is these concepts clear? Is everything clear? Yeah, definitely. At the rate of autumn, it will be helpful, very much helpful. It will be helpful for you. But it will be helpful for those only who have basically worked, who have, prepared a lot, who are basically, what we call, ready to give NEET examinations on 3rd May. Yes, everything is clear. Okay, Meena, thank you. After this. Another is propene can be converted into propan-1-ol. Have a look. This is propene. You have to convert propene to propan-1-ol. That means you have to add water. But this water should be added according to anti-Markovnikov's rule. Now, you have to convert this into 1-propanol by oxidation. Indicate which set of reagents among the following is ideal. Have a look. When you use, KMnO4, alkaline KMnO4 means Bayer's reagent. And osmium tetraoxide both will do synhydroxylation. That means in presence of these, what will happen? This pi bond will be broken and OH will be added from the same side. That means syn hydroxylation will take place. But here it's not syn hydroxylation, it is 1-propanol. That means it's not dihydric alcohol, it's monohydric alcohol. After that, B2H6 and alkaline H2H. This is hydroboration oxidation. Yes, this is an indirect hydration of, alkene according to anti-Markovnikov's rule. That means addition of water should be according to anti-Markovnikov's rule. So exactly it's this one. After that, it's ozonolysis. No, it will result upon ozonolysis. It will result in the formation of CH3CHO and then formaldehyde. I mean to say here aldehydes will be obtained from this alkene. So we don't want aldehyde, we want alcohol, that too 1-propanol. That means 1-propanol means OH, negative part of water, should go to that carbon-carbon double bond which is having more hydrogens. That means anti-Markovnikov's product should be this. So it's only possible when we do hydroboration oxidation of this alkene. I hope this is clear. I hope this is clear. Come on, dear students, let me know quickly. Am I clear? Come on, my dear students, let me know quickly. Am I clear? Am I clear? Am I clear? Am I clear? Come on. Yes, that's great. That's great, my dear students. Okay. After that, we will be having another question. Match the reagents with the product. List 1 is this, list 2 is this. Now, reaction of phenol. Whenever takes place with NaOH, it first results in the formation of sodium phenoxide. After that, carbon dioxide and H positive. Which type of reaction is this? This is Kolb's or Kolbe's Schmidt reaction, or Kolbe's reaction, or carboxylation of phenol. That means salicylic acid will be obtained over here. So A will result in the formation of 4. A4, that means either it will be A or it will be D. It will never be B and C. After that, aqueous NaOH, chloroform and H positive. This is known as when phenol is treated with chloroform in presence of aqueous NaOH followed by acidification. This is known as Reimer-Tiemann reaction. That means salicyldehyde will be the major product. Salicyldehyde. That means B is 3. So our option will be option number D. But still, we will check out. Phenol on treatment with zinc dust gives benzene. That means phenol on presence on treatment with zinc dust gives benzene. That means C will give 2. Yes. After that, on treatment of phenol with Na2Cr2O7 H2SO4, that means it's a strong oxidizing agent. It will result in the formation of benzoquinone. That means D will give 1. So our option number D is the right option. Let me know quickly. Exactly. Ananda is correct. D is the right answer. What about others? Am I clear? Come on, my dear students. Am I clear? Okay, it's clear. After that, we will be having another question. Phenol on treatment with zinc dust. Have a look. This is phenol. Listen, I can write down answer directly, but I want to, show how you have to proceed basically through these questions. Now, it's phenol. How you have to approach these questions? Phenol on treatment with zinc. It results on treatment with zinc dust. It simply loses this oxygen and results in the formation of benzene. After that, benzene on treatment with CH3Cl. And that too in presence of anhydrous AlCl3. This is known as Friedel-Crafts alkylation reaction, and we will get toluene over here. Why? Because both these result in the formation of an electrophile, and that electrophile is methyl carbocation. So after that, we will result in the formation of what we call this methyl benzene. This methyl benzene upon treatment with, KMNO4 oxidizing agent, strong oxidizing agent, it will simply convert the CH3 into COH. So we will get benzoic acid. Over here. So benzoic acid is the right option. Now, am I clear? Quickly, let me know in the chats. Am I clear? B is the right answer. Exactly, Subala. Exactly, B is the right answer. Ananda, B is exactly. Kanmani, B is the right answer. Exactly. God bless you all. Ananda. At the rate of Meena. Yes. Everyone. This is clear. After that, we will be having another question. The major organic compound in the reaction. Now have a look. This is basically an unsymmetrical ether. Whenever unsymmetrical ether is treated with HI, and that too at 273 Kelvin or at 373 Kelvin, that means at high temperature. Now what will happen? Reaction takes place either via SN1 or SN2. But for that purpose, reaction basically neither this is having tertiary group, neither this is what we call tertiary alkyl. When neither alkyl group present on right side of oxygen or on left side of oxygen is tertiary, reaction takes place via SN2 mechanism, and that means negative part of this, that means I here or X minus here goes to that alkyl group which is smaller. It takes place via SN2. So here CH3 will acquire I, that means you have to break this bond, then it will be CH3 whole to CHOH, that means isopropyl alcohol on one side and CH3I on another side. That means it will be option number C. It will be option number C. Now let me know quickly, is this clear? Is this clear? Is this clear, dear students? Exactly, Subala. It will be yes, Subalakshmi, exactly, it's C. Yes, Vishwa, it's C. At the rate of believe, it's C. Anonymous, yes, great, that's great. After this, we will be having another reaction by which benzaldehyde cannot be obtained. Benzaldehyde cannot be obtained. What is benzaldehyde? Benzaldehyde means this one, benzene carbaldehyde. It's this one. Now, it cannot be obtained. How it cannot be obtained? First of all, this is Rosenmund's reduction. Remove this Cl and use H, so it will become CHO. That means with the help of Rosenmund reduction we can prepare benzaldehyde. This is benzene COHCl in presence of AlCl3. This is known as Gattermann-Koch reaction. With the help of this, yes, we can simply what we call form benzaldehyde. After that, this is the reaction. Because COH on treatment with this and this, it will not form any product, so it will not undergo any further reaction. So this will not form benzaldehyde. This is toluene on treatment with chromyl chloride followed by hydrolysis. This is known as Itard's oxidation or Itard's reaction. This also forms benzaldehyde. So Itard's reaction gives benzaldehyde, Gattermann-Koch reaction gives benzaldehyde, and this Rosenmund's reduction also gives benzaldehyde. So question is, which cannot be prepared? Benzaldehyde cannot be prepared from which of the reaction? So it is reaction number C. Option number C. Am I clear? So please take session where you will cover at the important and high weightage topics, please, sir. Yeah, definitely. For you, we are always there for you. Unacademy is always there. Unacademy NEET English is always there for you. Whatever is in our hands, we will do that for you. So you don't have to worry about that, because everyone here is basically thinking of how you can crack NEET examination. So don't worry about that. We will do whatever is good for you. So don't worry about that. After that, we will be having another reaction like this, and reaction is CH3CHO. CH3C double bond O and H. CH3CHO upon treatment with lithium aluminium hydride followed by hydrolysis. So first of all, we have to break this bond and we have to add H and H to this. That means we will get a reduction of aldehyde and results in the formation of ethanol. This ethanol on treatment with H2SO4 and heat undergoes intramolecular dehydration reaction, and it will result in the formation of ethene. Now, this ethene on treatment with HBr, undergoes electrophilic addition reaction, and it will result in the formation of ethyl bromide. That means this is an alkyl bromide, alkyl halide. Alkyl halide, ethyl bromide on treatment with aryl halide, that means bromobenzene, in presence of sodium and dry ether. You know, this reaction is alkyl halide and aryl halide on treatment with sodium. If only alkyl halide is there, it's Wurtz reaction. If only aryl halide with sodium and dry ether is there, it's Fittig reaction. But alkyl halide as well as aryl halide, it's Wurtz-Fittig reaction, and the major product of Wurtz-Fittig reaction is alkyl benzene. That means this is ethyl benzene. Now have a look. Is there any option known as ethyl benzene? Yes, this is the right answer. Let me know quickly. Am I clear? Am I clear? Am I clear? Exactly. That's great. It's exactly what's fitting. Yes, ethyl benzene will be the product. Nice. That's great. After that, we will be having reaction between benzaldehyde. Have a look, dear students. Reaction between benzaldehyde. Benzaldehyde is this one. Benzaldehyde is this one. It's this one, benzaldehyde. With acetophenone. Acetophenone with this. Acetophenone is this one, C double bond O and CH3. That means this is having alpha hydrogens. This is not having any alpha hydrogen. That means different aldehydes or different carbonyl compounds having alpha hydrogen in presence of dilute NaOH. Dilute NaOH. This is known as cross aldol condensation. Cross aldol condensation. This is cross aldol condensation, and its product will be alpha beta unsaturated, what we call aldehyde, like this, or alpha beta unsaturated carbonyl compounds. This is less reactive. This is less reactive towards nucleophilic addition reaction, because nucleophilic addition reaction is shown faster by that carbonyl compound which is aldehyde. This is aldehyde, this is ketone. Why? Because this aldehyde is not having, say steric repulsion more or steric crowding more. More steric crowding, lesser will be the nucleophilic addition reaction. Or this is having electron donating groups, more electron donating groups, lesser will be the, say reactivity. This is more reactive. More reactive. From more reactive, you have to remove this double bond O, and from this you have to remove 2 alpha hydrogens. So its product will be like this. It will be like this. It will be CH, double bond CH, single bond C double bond O, and then you will be having product like this. So this is alpha beta unsaturated ketone. So this is cross aldol condensation in nutshell. So cross aldol condensation is this one. So whenever you are having two different aldehydes, two different ketones, one aldehyde and another ketone, that means different carbonyl compounds. But if both are having alpha hydrogens, cross aldol. If one is having, say at least alpha hydrogens, cross aldol. If none is having, what we call alpha hydrogens at that time, if both are different aldehydes and both don't have any alpha hydrogen and reaction takes place with base, at that time it's cross Cannizzaro reaction. Now, this is clear. Okay, crystal clear. Thank you. God bless you. After that, this is a question. Have a look. We will be having an X formula CH3CH2OH. That means CH3CH2OH, C2H6. CH32H6O means it's an alcohol. Okay, that means it is simply X will be CH3CH2OH. This is X. This X upon, say treatment with copper, hot copper, it will result in the formation of aldehyde, because dehydrogenation takes place. So this is Y, this is A, not Y. This is A, this is A. After that, this A, as this is an aldehyde, upon Toland's treatment with Toland's reagent, it will give silver mirror. Okay. Then this upon treatment with, OH having negative charge and heat, that means it is aldol condensation, because OH minus means alpha hydrogens there. So aldol, after that heat, dehydration of aldol, so aldol condensation, its aldol condensation product will be CH3CH, double bond CH, single bond C, double bond O, and then H. It's simply alpha beta unsaturated aldehyde. So it will be actually like this, CH3, it is C double bond O, and after that another will be like this, CH3, C double bond OH. Then you will simply lose water molecule. It will be CH3CH, double bond, say for example, this is CH, CH3CH, double bond CH and CHO. It will be like this. So this will be the, this will be your Y. This will be Y. After that, on treatment with NH2NH, CO NH2, this is semicarbazide. As aldehyde on treatment with this result in the formation of semicarbazone like this, double bond, it will be H2 and O, which will result in the formation of water. So it is NNH, then CONH2. So this is semicarbazone. This is semicarbazone. So this is Z. So Z is semicarbazone. Semicarbazone. So what is the question? You have to find out A. A is, this is what we call methanol or acetaldehyde. Methanol or acetaldehyde. So Y is 1, 2. That means it is but. but-2-enol, but-2-enol, and then Z is, I mean say this, and this is ethanol. This is not methanol, sorry, this is ethanol, not methanol. This is ethanol. Okay, ethanol, ethanol. Okay, X is, have a look. A is methoxymethane, no. A is ethanol. A is ethanol, yes. A is ethanol, no. A is methoxymethane, no. So A is ethanol. This is exactly answer. So X is ethanol, yes. Y is but-2-enol, yes. And Z is semicarbazone. I hope this is clear. Let me know quickly. Is this clear? Let me know quickly. Is this clear? Is this clear? Let me know quickly. Let me know quickly. Yep, sir. Okay, okay. That's great, Pamela. That's great. That is great. That is great. After this, we will be having another question. And question is, which one is most reactive towards nucleophilic addition reaction? Remember, towards rate of nucleophilic addition reaction is simply directly proportional to magnitude of positive charge. Magnitude of positive charge. Simple formula or simple trick. It is directly proportional to magnitude of positive charge on carbon of carbonyl. Carbon of carbonyl. Now, the question is, magnitude of positive charge will be more if that carbon is attached with electron withdrawing group, and if that carbon is attached to electron donating group, it will be lesser. And in general, we will be having aldehydes will show more faster, I mean say nucleophilic addition as compared to ketone. Now, have a look. First of all, this is an aldehyde, this is ketone, this is aldehyde, this is aldehyde. So leave ketone, we have to check among aldehydes. This is aldehyde and this ring will donate electron. This CH3 as well as this ring will donate electron, but because of NO2, it will withdraw electron. When it withdraws electron, positive charge of this carbon will increase. When its magnitude of positive charge is increased, rate will be faster. So it will be simply this one. Simply D option is the right answer. Let me know quickly. Is this clear? At the rate of Ananda, D, great. Pamela, D, great. Arey, wow, that's great. Kanmani, electron withdrawing group. That's great. That's great. That's great. You will simply do best in your NEET examines. That's great. I'm very much happy. I'm very much happy for you. Okay, that's good. That's good. After this, CH3CHO and CH3CH. C6H5CH2CHO. Let me tell you, this is aliphatic aldehyde. This is also aliphatic aldehyde, but we can simply say this is aryl derivative. This is aryl, I mean say what we call substituted aldehyde. This is aryl substituted aliphatic aldehyde. Okay. Can be distinguished chemically by, now have a look, Benedict's test. Benedict's test is not shown by aromatic aldehyde, but this is not aromatic aldehyde. So both will show Benedict's test. Iodoform test. This will show iodoform test because iodoform test is shown by those carbonyl compounds which are having this group. So this is having this group, but this is not having, I mean say CH3 at alpha, so it will not show. So iodoform test. With the help of iodoform test, we can distinguish this. Tolan's reagent. Both aldehydes. That means Tolan's reagent test is given by all the aldehydes. Fehling solution and Benedict solution. It's given by aliphatic aldehydes. And both are aliphatic aldehydes. So it cannot be, I mean say, substituted, or it cannot be what we call replaced. It cannot be distinguished with the help of Fehling, Benedict's or Tolan's test. It can be, I mean say, simply separated or distinguished by iodoform test. After that. But first of all, let me know in the chats quickly. Let me know in the chats quickly. Good evening, sir. This is Akshita. I am scoring 530 in my mock test, sir. I am BDS, BCD, sir. Can I get MBBS seat? Yes, definitely. You have to be very much positive. You have to trust your, I mean say, what we call yourself. You have to trust yourself very much. You have to trust your preparation as well, and do your best. God will do the rest. So don't think about result. Just try to do your best. That's it. After that, we will be having another question. Which one of the following on treatment with? These are all aldehydes. This is the ketone. Leave it because it's 50% aqueous NaOH. That means this question is all about, as one of the this is alcohol and another is acid. That means this is a Cannizzaro reaction. Question is about Cannizzaro reaction. And remember, Cannizzaro reaction is shown by what? Cannizzaro reaction is given by only aldehydes, and that too which does not have any alpha hydrogen, Ketones do not show. These aldehydes with alpha hydrogen cannot show, so it will be shown by only C6H5CHO among these, because C6H5CHO, that means benzaldehyde, does not have any alpha hydrogen. So it will result in the formation of C6H5CH2OH, one alcohol, another C6H5COONA as oxidized product. So one product is reduced, another product is oxidized. So self-oxidation and reduction of this benzaldehyde will take place. So this is what we call the option. Correct option is option A. Now, tell me, am I clear? Yes, A is the right answer, exactly. A is the right answer. Exactly, my dear lovely students. A is the right answer. Yes. Now, another question. As we have 45 questions. So now it will take much more than, it will be maximum. I will take, 10 to 15 minutes to cover this session. Okay. So be with me. It's only 10 to 15 minutes remaining. Now, this aldehyde does not undergo aldol condensation. Why? Very, very simple question. Why this does not show any aldol reaction? Why? Because it does not have any alpha hydrogen. So it does not have any alpha hydrogen. 3 electron donating methyl groups, cleavage taking place between CCH2, absence of alpha hydrogen atom in the molecule. Yes, this is the right answer. After that, question is like this: benzene, COHCl anhydrous, AlCl3, CuCl3. This is known as Gutterman. That means A is having 2. A having 2, that means it will be the first option, because others will be A4, A3, A1. So this is the right answer. But let us check others as well. Now this is having a ketone containing CH3 group at alpha with respect to C double bond O. So it can, in presence of sodium hypohalite or halogen in presence of base, it will result in the formation of haloform reaction. That means B is 3. That's B is 3. Yes. After that, this is having, this is alcohol and as well as carboxylic acid. When alcohol and carboxylic acids are reacted together in presence of acid, esterification takes place. That means C is esterification. C is esterification means 4. Exactly. This is having carboxylic acid having at least 1 alpha hydrogen. This is having 2 alpha hydrogens in presence of red phosphorus. Halogen in presence of red phosphorus followed by water. This is known as Hell-Wohlhardt-Zelensky reaction, because that is generally alpha halogenation reaction of carboxylic acid containing at least 1 alpha hydrogen by using halogen in presence of red phosphorus followed by water. That means D is 4. D is 1. So it is the right option. After that, my dear students, we will be having like this. Have a look. First of all, we will be having an alkyl benzene on treatment with number 1 KMNO4 KOH followed by acidification. First of all, this alkyl group is converted to COH. That alkyl, that carbon which is attached directly to benzene, that means benzylic carbon, if it contains at least 1 hydrogen on treatment with strong acidic, strong oxidizing agents, it is it's converted to benzoic acid first of all. After that, on treatment with Br2, that means FeCl3, that means this is an electrophilic substitution reaction. Br2 positive will go to that position which is, electron rich. But we know COH is electron withdrawing. It simply decreases electron density at ortho and para position, which means it's a meta-directing group because it decreases electron density at ortho and para. So Br will go to meta position. After that, dear students, finally, it is treated with C2H5OH followed in presence of acid. That means OH of carboxylic acid and H of this, alcohol will result in the formation of, ester like this. So COOC2H5 and Br at para position will be our product. So have a look and tell me which option is the correct option. COOC2H5, Br at meta position is the right option. So this is our answer. After that, which of the following represents the correct order of acidic character acidity? We know acidic character or strength of acid is directly proportional to electron withdrawing group. These all are electron withdrawing groups, F, Cl, Br, these are all electron withdrawing groups, but in CH3COH there is electron donating group. So it is directly proportional to electron withdrawing group and it is inversely proportional to electron donating group attached to acid. That means the strongest acid will be that in which stronger electron withdrawing group is attached. So it is F, then it is Cl, then it is Br, and after that it will be CH3COH. After that, another question is, in a set of reaction, propionic acid yielded a compound D compound is. First of all, whenever this COH is treated with SOCl, this OH will be replaced, so our B will be CH3, CH2, then it will be COCl. When it is treated with ammonia, this Cl will be replaced, nucleophilic acyl substitution will take place. It will result in the formation of CH3CH2, C double bond O, and then Cl will be replaced by NH2. So this is amide. But on treatment with this one, this is Hoffman degradation or Hoffman bromamide degradation reaction. Remove this C double bond O and you will get a primary amine like CH3CH2 NH2. That means ethyl amine or ethane amine will be the product. CH3CH2 NH2 will be the product. So this will be the product. After this, dear students, the amine that reacts with Hinsberg's reagent to give an alkali but insoluble. If it is soluble, then amine will be primary amine, and if it is insoluble, amine will be a secondary amine. Secondary amine functional group is NH. This is primary amine, NH2. This is tertiary amine, so we know it is secondary amine. So this is the answer, my dear students. After that, which of the following amine will give carbyl amine test? Carbyl amine test is only and only given by aliphatic or aromatic primary amines. So here this is a secondary amine, this is a tertiary amine, this is secondary amine, this is primary amine. So carbyl amine test will be given by primary amine. After that, dear students, match list 1 with list 2. Have a look. Gabriel synthesis or Gabriel thalamide synthesis. What is the product formed in Gabriel thalamide synthesis or Gabriel synthesis? It is primary amine. So have a look. A3. That means either A or B is the right option. Among these two, 1 or 2, A or B is the right answer. After that, Kolb synthesis. Kolb synthesis means Kolbe's reaction or Kolbe's, say Schmidt reaction or carboxylation of phenol. That means salicylic acid. That means B4. So this is the right option because B4, B3 is not the right option. After that, Williamson synthesis. Williamson synthesis will form ethers. Great. After that, Etard reaction will form what we call benzaldehyde. That means C is having 2 and D is having 1. C is having 2, D is having 1. After that, we will be having another question, and this question is like this. First of all, you have C double bond OH, and to that Br is present at meta position. Remove this OH by Cl. So you will get like this. After that, it is NaOH Br2, Hoffman bromamide reaction. First of all, it is NH3. Now, remove this Cl by NH2. Remove this by NH2. Here it is Br at what we call meta position. After that, treat this with NaOH Br. Whenever amide is treated with this is Hoffman bromamide reaction. Remove this C double bond O. We will get NH2 and Br at meta position with respect to each other. Have a look. This is NH2, this is Br. They are at meta position with respect to each other. So this is the right answer. After that, we will be having this one. Very, very, very simple reaction. Have a look, dear students. Have a look. This is diazonium salt, benzene diazonium chloride, on treatment with Cu2Br2 HBr. This is known as Sandmeyer's reaction. Remove this diazonium by bromine. That means we will get bromobenzene. After that, treat it with magnesium and dry ether. What will happen? Between C and X, magnesium will be incorporated. That means it will result in the formation of phenyl magnesium bromide, a Grignard reagent. And in Grignard reagent, this is negative part, this is positive part. On treatment with strong, that compound which contains acidic hydrogen, this negative part will abstract hydrogen and this OH will leave. That means it will become, this bond will be broken. It will result in the formation of benzene plus it is OH which has been left over here. It will form a bond with this one, hydroxy magnesium bromide, and benzene will be the product. So benzene will be the product. Let me know in the chats quickly. Am I clear? Am I clear? Let me know in the chats quickly. Because we have to solve only 2 questions now. 43 questions have been solved. Come on, my dear students. 42 or 43 have been solved. Maximum we have to solve 3 more questions now. Great. That is great. That is great. That is great. After that, another question is like this. Have a look. This is benzene diazonium chloride. This is aniline. So coupling reaction takes place, and coupling takes place. This benzene diazonium chloride will simply be added to this aniline at para position. So it will result in the formation of para amino or 4-amino azobenzene, a yellow dye. So what will be the product? 4-amino azobenzene. This will be the product. This is very, very, very simple reaction. Coupling reaction is this. Yes, at the rate of AU NT26, I will be sharing this on a Telegram channel, and the Telegram channel is of Unacademy NEET English. You can search that on Telegram. So I will, share the PDF of this session. After completing the session, I will share PDF of this as well. Now, after this, we will be having another question. Have a look, have a look. This is what we call aromatic amine, but that too a primary aromatic amine. When primary aromatic amine is treated with NaNO2 HCl, obviously temperature is not given. You just take temperature at that time 0 to 5 degrees Celsius. That means this is a diazotization reaction. It will result in the formation of benzene diazonium salt. After that, this is treated with CuCN. That means a Sandmeyer reaction in which the Cl will be replaced by CN. So you will get this one, benzonitrile will be formed. After that, this is treated with H2Ni. C triple bond N is converted to CH2NH2. That means we have to add hydrogen. This is reduction across carbon triple bond nitrogen. So it will result in the formation of this one, primary amine. After that, but here this primary amine is now aliphatic primary amine. This upon treatment with nitrous acid results in the formation of what we call benzyl alcohol. Because primary amine, if it is aliphatic, remove NH2, form a carbocation. After that, you have to check whether carbocation undergoes rearrangement or not. Here it is benzyl carbocation, it will not undergo rearrangement. Finally, OH will be attached to this. So it will result in the formation of C6H5CH2OH. C6H5CH2OH is option number D. Option number D. Now, my dear students, this is the question from what we call biomolecules. Which one of the following sets of monosaccharides forms sucrose? Which forms sucrose? You know, sucrose is a disaccharide, and that is formed by glycosidic linkage, and that glycosidic linkage takes place between glucose and what we call fructose. Alpha D glucopyranose or alpha D glucose, and that too carbon 1 of alpha D glucose that combines with carbon 2 of what we call beta D fructofuranose, or beta D fructose. So it's alpha D glucopyranose, alpha D glucopyranose. No, this is galacto, this is gluco, and beta D fructofuranose. That means this is the right option. But remember, it's 1 and 2 glycosidic linkage. 1 of glucopyranose and glucose, and 2 of what we call fructose or fructofuranose. So this is the right option. This is the right option. This is from biomolecule chapter. After that, in DNA, the complementary bases are, remember, in DNA, complementary bases are according to Chergov's rule. What was that Chergov's rule? That there must be equal amount of purine bases and pyrimidine bases. That means adenine will simply compare with, will couple with, will form hydrogen bonds with thymine, and guanine with cytosine. That means it is adenine and thymine, guanine and cytosine. That means it is option number 1. So, my dear lovely students, this is all about today's session, and I hope you have enjoyed today's session, and thank you. God bless you all. I will be sharing PDF of today's session with you on Telegram channel of Unacademy NEET English. And I hope everyone among you will get a very, very good GMC. And I will be waiting for your comments, but after end of this session, when this live stream is ended, I will be waiting. I will be surely waiting for your comments that how much you like today's session, and I will be waiting for your comments after end of this session. After end of this session, I will be waiting. I will be waiting. So, this was all about today's session. That's it. So, take care. God bless you and good night. Bye-bye. Love you all. Thank you and God bless you all.